Hello, everyone. Welcome to Theo-MathProblemSolver. In this particular episode, I'm so excited to take you through the journey of finding area between two curves. And at this point, if you have not subscribed, please do so. Like, comment, and then share my content with your colleagues, with your loved ones. And let's keep, spreading this fantastic good news. All right. So suppose that, so we want to start. So suppose we have two functions, okay? So we have f and g to be a continuous function, okay? To be a continuous function. And suppose that, f of x is greater or equal to g of x, okay? In other words, the graph of f of x lies on top of the g of x over this particular interval, okay, this particular closed interval. Then we claim that the area of the region between these two curves, uh, uh, you know, from A to B will be given by let me extend it a bit. Will be given by um, such a very nice integral, okay? Okay. So we claim that the area will be given by this. But let me give you a pictorial picture so that you'll be able to, have a feel of what I'm trying to talk about. Suppose we are in the XYZ, you are just in the XY plane. Okay. Suppose we are in the XY plane. And let me use a different pencil for me to elaborate what I want to say. So suppose that um, the the graph of the f of x is of this nature. So let's suppose that f is of this nature. So this is my f. Then let me use a different pencil. And suppose that this. Oh, let me use a different one. Suppose that the graph of g is like this. So this is my g of x. Okay. Then so remember that x takes its value. So that remember these two curves are bounded by a and b. They are bounded by a and b. So remember that these two curves are bounded by a and b. Okay. If they are bounded by a and b, then we claim that the area will occur within this region. Okay. So the area will be sandwiched by these two curves. Okay, so our area would occur here. So this is our area. Is that okay? So it means that our area will be within this region. Okay, very good. So we claim that for us to find the area of this, what that we do is that we take the integral over this range over this interval, which is a to b, then we just find their difference. Okay. And if since we are so over here, the technique we kind of use is that we are integrating vertically. Okay, we are doing vertical integration, which means that or we are doing vertical integration, or which we have the vertical slicing. So we are slicing vertically. So on that note, when we look at it that way, it just means that f would eventually lie on top of the g. As we see, the graph of the f lies on top of g, okay, because we are integrating vertically. When that happens, that's what we are going to have. All right, and so for us to appreciate this, it's good that at least we kind of look at one or two examples so that we'll kind of appreciate what all that we are doing. So let me bring in an example. So um as a good example, now let's look at this problem and see how best we can solve this. Now, what would be if I ask you to find the area if I ask you to find the area of the region, that is bounded. Okay. So that is bounded by the graphs of, so the first function f of x is equal to 2x plus 1, and g of x equal to, let's say, x squared plus 1. How do we find the area of the region that is bounded by the graphs of these two functions? And that is the first problem of the day. All right, so let's go straight to the point. So to solve this, what that we need to do is that, to solve this, the first thing to do, or the most easiest way to do is to since you may not know which graph is lying on top of the other, the best is to grab them. Okay, very important. Is the best thing to do is to grab them. So with the graph of this, the graph of this will be what? So the graph of this, so in the xy plane, we'll have, so we claim that the graph of G would pass through 1. Okay, the graph of G will pass through 1. So we have the graph of G to be this, to be this. Okay, so this is our graph of G. So this is our graph of G. Okay, it will pass through 1. So which means at this point we're going to have 0 and 1. Okay, and then we see that the graph of f would also pass through 1. So in that note, we're going to have, so let me use a different pencil. You're going to pass through 1. So we are going to have also to pass through. So this is our graph of f. Okay, very important. So now for us to solve this, so it means that the area would occur within this region. Is that okay? So that we have the area here. So this side is going to be our area. Okay, so our area will be within this region. Now, what we need to do is that we are going to do what we call the vertical slicing. So with the vertical slicing, so I will have this as my vertical slicing. With the vertical slicing, we see that the graph of f lies on top of G. Okay, so since the graph of f lies on top of G, what happens is that we just have to subtract the G function from f. Okay, so which means that my area would then be equal to what? Would then move from what? A will be bounded by a and b, and then we have f of x minus g of x dx. Okay, but then at this point, it's important for us to know what is the point of intersection, or the interval which this area exists. So on that note, we may want to sort of try and find that. Okay, very important. So we need to find that. So from this point, already we know one point of intersection is here. Another point would be the intersection here. So from this, it shows that our point of intersection will be 2 and 5. Okay, or the easiest way to find the point of intersection, which means that, so we just have to pick the x component. So x component will start from where 0 to 2. Or the easiest way to find this is that we will just equate. So we need to find the point of intersection. So let me just erase this. So find point of intersection. Okay, so find the point or the intersection point. Very important. So to find the intersection points, what happens is that we need to equate them together. Okay, so your f of x should be equated to g of x. Okay, what is your f of x? From the question, our f of x is what? So our f of x is 2x 2x plus what? 2x plus 1, okay? And the g of x is what? X squared plus 1, okay? So on that note, you're going to have your x squared plus x squared. So when you perform your arithmetic, you should have x squared minus 2x should be equal to 0. On that note, you're going to have, when you factor out x, you're going to have something beautiful as so. Okay, so these are your point of intersection. So that's what we have here. So having found this, we now go straight to the point and find our A. So our area, okay? So on that note, our area will be from 0 to 2. Then we subtract the two functions. Okay, you subtract g function from from the f of x. Okay, very important. So we have 2x plus 1, then minus x squared plus 1. Okay, is that okay? Very important. So what do we get when we do that? By simplifying the integrand. Okay, the last I mentioned that the whole of this, the function in an integral is called integrand. Okay, said it's called integrand. Now that when you simplify the integrand, you should be able to get 2x minus what? Minus x squared. Very important. Good, good, good. So now we have to just, according to the fundamental theorem of calculus, as we explained in our previous episode, we should be able to, applying the fundamental theorem of calculus, should be able to solve this. Okay, and this by simplifying this, we should get what? X squared. So we increase the power by 1 and divided by the increased power, okay? And that's what we explained in our previous episode. And by simplifying this a bit, you should have 2 to the power 2 minus what? 2 to the power 3, all of that minus what? 0 squared minus 0 cubed on that. And then we should have that. And by using the calculator to simplify it a bit, you should have 4 on 3. So the area that is the area of the region that is bounded by the graphs of these two functions would be 4 on 3. Very, very, very important. Very, 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 very important. And at this point, if you have not subscribed, please do so. Turn on your notification button so that anytime I release new content, you'll be the first to receive that. Very, very, very important. If you have any questions, please let me know so that I could help you out. Very important. So let's take another one more examples for us to be able to understand it better. Now the question, what does the question say? The question says find the area of the region enclosed by the parabolas, okay? Y equal to x to the power 2, and then y equal to 2x minus x squared, okay? So how do we solve this? Very, very, very important. How do you solve this? So let's go to our solution. How do we solve such a problem? And as I mentioned, the easiest way to solve this is when you graph it. When you graph it, you have a complete picture of what you are doing. Okay. So the easiest way to graph this, to do this is by graphing. Okay. So in our XY plane, now let's do our graphing. Now, what is the graph of y equal to x squared? So obviously it will pass through the origin, right? So it will pass through the origin. So since it is passing through the origin, we should have something beautiful as this, okay? So this is our graph of y equal to x to the power 2. Now, what is the graph of what is the graph of let me use a different pencil. The graph of y equal to 2x minus x squared. What is the graph of that? It will eventually also pass through the origin, right? But it behaves like a concave down, right? It behaves like a concave down. So on that note, we're going to have something it might pass through the origin, okay? But let me take my time and draw it well. So it has. So on that note, what is your point of intersection? So we see that this region will be the point of intersection, okay? So this is the area that is enclosed by the two curves, okay? Very good. So this is our area, okay? So this side is your area, is what we call the area. Is that okay? So on that note, let me use a different pencil. So this will be your, so this side is your area, okay? That is enclosed by these two curves. So if we are doing, vertical slicing, so if you are doing vertical slicing, so it means that the graph of, if you are doing the vertical slicing, we see that the graph of y equal to 2x minus x squared lies on top of y equal to x squared. Okay, very important. Now, by doing that, it means that our area will just going to be the integral from where? But before we do that, it's just going to be the integral from one point, which is from A to B, but we have not already done that. And the easiest way, as I mentioned, to do that, already we know one point because since it passed through the origin, so it means that it will start from 0 and end somewhere here. But what is that? The easiest way to do is to equate them, is to find their point of intersection, okay? How do we find a point of intersection? So before we do this, let's find a point of intersection. Very, very important. Let's take note of that. So we need to find a point of intersection, okay? So point of intersection, very, very, very important. So point of intersection. And by finding the point of intersection, we just equate the two, graphs together, or the two parabolas together, okay? So what do we get? So we just have to equate them together. So we have, the first one, we have 2x minus x squared, and the second parabola, we had what? X squared. Is that okay? And by doing that, we are going to have what? So we are going to have what? So we're going to have 2x squared minus 2x equal to 0. So on that note, when you factor out 2x out, you're going to have x minus what? Minus 1 equal to 0. So then you're going to have x equal to 0 or x equal to what? 1, right? As our point of intersection. So it means that this point, you're going to have what? 1 over here. Okay, very good. So it means that this area enclosed by these two curves will be bounded by 0 and 1. Okay, so with that, since we've already realized that, it means that our area that is enclosed by these two curves within the region of 0 to 1. Now, mind you, when we do vertical slicing, with the graph of y equal to 2x minus x squared will be on top of the other ones, okay? So the graph of 2x minus x squared is on top of the other one, okay? Is that okay? Good. Now, when we perform the arithmetic, when we simplify the integrand a bit, you should be able to have what? You should be able to have 2x minus what? Minus 2x squared, okay? And when you solve that, you should be able to have what? When you can factor out 2, and by simplifying that, you should be able to have what? X to the power 2 on 2 minus x to the power 3 on 3. Then we evaluate that under the interval 0 to 1. Okay, according to the fundamental theorem of calculus. Is that okay? And by using a calculator, you should be able to get a very good answer. So at this point, I may not do that, but I've already explained what we can do. Or this is straightforward. So first you plug in the upper limit, and this is your upper limit. So we plug in that, and that gives you 1 squared on 2 minus what? 1 cube on that. But remember, the other one will be 0 because of the x component there. That will be 0. So we can simplify that, and you get your result. Is that okay? Very good. And that will be your result. That will be the area that is bounded by the graphs of these two, parabolas. Let's look at another interesting example. Let's look at one more example under this. Is that okay? I believe everybody is okay with this interesting stuff that we are doing. If you don't understand, please let me know. Please. Very, very, very important. Just in case you do not understand, just let me know, and I will take it further to kind of explain some stuff to you. And at this point, if you have not subscribed, please do so. Put on your notification button so that anytime I release new content, you'll be the first to receive that. Okay? Very, very, very important. So let's take note of that. But at this point, if you also have some questions that you want me to address for you, please, do so, and I can kind of do that for you. Share this content with your colleagues, with your loved ones, and let's keep, the message spreading. Very, very, very important. Very, 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 very important. So let's take note of that.